Hi, this is Maria Caulo, and I'm presenting a study about the knowledge transfer in modern code review. Code review is the process by which peer developers inspect the code written by a teammate to assess its quality, to recommend changes, and finally to approve it for merging or not. The modern code review is change-based, and here we can see an example of changes on GitHub. Our research question investigates to what extent the experts of a publicly shared project can transfer knowledge to developers who want to modify it, by means of the code review contained in these modifications. Knowledge can be classified as either explicit, which can be spoken and codified in words, figures, or symbols, or tacit, which is embedded in individuals' minds and is hard to express and communicate to others. We focus on tacit knowledge acquired by developers over time, which cannot be easily seen and quantified. We investigated whether the experience gained by receiving feedback during code review improves the quality of developers' future contributions to open source projects. So our hypothesis tells that the quality of developers' contributions to software projects will increase with the experience gained from their past reviewed pull requests. Here's something about pull requests. They are formal requests to contribute to the source code of a shared repository. So this is a pull request on GitHub, and we have the author who left a message describing what he wanted to change and the positive answer that the reviewer Kino gave him. Here we can see Kino and the other two reviewers of this pull request, and in particular, one requested some changes and the other one only left one or more comments. So we decided to consider past reviewed pull requests as a proxy of the knowledge transferred. Here's the context selection. We chose 12,000 users who created their GitHub account in 2015, that is 1,000 per month. So we could observe about 4 years of contributions even for users who joined it at the end of 2015. To do this, we used GitHub Search API, and we thought a 4-year time window to be long enough to study the knowledge transfer over time. But 9 users made more than 1,000 pull requests, so we decided to exclude them because of API limitations, and more than 11,000 users made less than 30 pull requests, so they made a very small amount of pull requests and we decided to exclude them. So only 818 users were selected in this phase. So we selected their closed pull requests to be sure that they underwent a code review process, that received at least one review comment, and that the comments received were not left by a bot. So we had the final set made of 32,062 pull requests. So we finally had 728 developers who made about 32,000 pull requests in about 5,000 software repositories where they contributed. To measure the knowledge, we used the number of reviewed pull requests a developer authored in the past, since we assume that the more closed and peer-reviewed pull requests a developer has, the more knowledge the developer gains. As another knowledge measure, we used the number of commits performed in the past by each developer before submitting each pull request to control if the quality of the submitted contributions is actually influenced by the knowledge transfer related to the code review, or if it's just a result of the increasing developers' experience over time. To measure the quality of the contributions, we used the acceptance rate of the pull requests made in the past, as well as their closing time. And in addition, we used the number of general comments left in the pull request conversation, but also the number of comments concerning the source code included in the proposed changes. Finally, we measured the sentiment polarity of comments in general and source code discussions by means of two tools, SentiStrength SE and Senti4SD. We built our dataset where each row is related to one pull request. The cells contain both the knowledge measures and the contribution quality measures, but quality measures are calculated in average form, basing on the current pull request and, in addition, the four most recent pull requests. As a result, it is possible moving on the dataset through a fixed sliding window. The average form of quality measure hasn't been calculated for the polarity of comments, which concerns only the current pull requests. We built two datasets representing two different scenarios. For the single project 1, the measures are calculated with respect to the repository where the developer made the current pull request. For example, today Ben wants to contribute to the PowerToys repository. Before today, he made 100 pull requests in 5 repositories, and PowerToys is included. Before today, he made 12 pull requests in PowerToys, and the number of past pull requests with respect to the pull request he is making today is 12. The number of past commits made before today depends on the repository where he is contributing. All the quality measures are calculated in the PowerToys context. For example, before today, Ben Trovato got no pull requests merged into PowerToys. On the contrary, today's pull request got accepted. So the average acceptance rate inserted in the row related to today's pull request is the 20%. Conversely, given a row of the cross-project scenario dataset, we computed knowledge and quality measures considering all the projects where the developer made the pull requests. For example, today Ben wants to contribute to an open source repository. Before today, he made 100 pull requests in 5 repositories. And the number of past pull requests with respect to the pull request he is making today is 100. The number of past commits made before today is independent from the repository where he is contributing as well. All the quality measures are calculated within the context of all the projects where he contributed. We used the number of past reviewed pull requests to split developers into 4 different groups based on the knowledge they gained over time. So we have low, medium high, and high groups. And we compared the quality of the submitted contributions among the different groups. In particular, we extracted the first, second, and third quartiles of the distribution for past pull requests, and we split the rows of our datasets. We performed the same grouping also for the number of past commits. We used box plots and Mann-Whitney test to compare the contribution quality measures in the different knowledge groups for both the scenarios and each of the experience measures. The p-values of the Mann-Whitney test are adjusted with Ohm's correction. The effect size is estimated through Cliff's delta in the 4 ranges, and we first removed outliers. These are the acceptance rate box plots resulting from the comparison between the 4 groups for both the single on the right and cross on the left scenarios, and for both the knowledge measures. We have past reviewed pull requests on the top and past commits on the bottom. Results of Mann-Whitney tests are statistically significant with a small effect size only in the cross-project scenario when grouping the by past commits and when comparing low with medium to high groups. It seems that developers are more likely to improve their pull request acceptance along with the increase of their committing experience. And we expected that. When grouping developers by past pull requests, both in the cross and single scenarios, there were no statistically significant results in the comparisons for the acceptance rate. But we expected that the higher the experience in making pull requests, the higher the acceptance rate. So these are the box plot for the closing time of past accepted pull requests, and also in this case we had a statistically significant result in the cross-project scenario when grouping the developers by past commit. But most of the times we found no impact of the knowledge acquired in past pull requests on the closing time. This may be due to the fact that more experienced developers tend to submit more complex pull requests. We expected the closing time to decrease with increase of knowledge, but this is only slightly supported by the statistical tests. Concerning the general comments received, we had a statistically significant result in the cross-project scenario when grouping developers by past pull requests, and in the single project scenario when grouping developers by past commits. It seems that developers who acquired more knowledge over time receive more general comments. We actually did not expect this, but maybe this indicates the higher complexity of the changes that high experienced developers have to implement. Conversely, developers in the higher group receive less comments than those in the lower groups in the context of the single project scenario when developers are grouped by past commits made. Concerning the source code comments received, we only had a statistically significant difference in the cross-project scenario when grouping the developers by commits. It seems that developers who have less experience in making pull requests receive more code comments with respect to high experienced developers who are not widely asked to change the code of the contributions. This is actually what we expected to find. Concerning the general discussions, the only statistically significant difference is in the comparison between low and high groups, with the polarity slightly more positive in general conversation of low experienced developers when grouping by past commits. Concerning the sentiment polarity of source code discussions, a neutral feeling prevails for each knowledge group, for each scenario, maybe because code review discussions mostly concern topics like defect detecting, reviewer assigning, contribution encouraging, and so on. So our results were mostly negative. We were not able to capture the positive role played by code review in knowledge transfer among developers, as was previously suggested in the literature. Maybe our negative result is caused by the way in which we measured the knowledge transfer in code review, the measures used to assess the quality of contributions over time, or maybe also the sentiment polarity assessment provided by sentiment analysis tools. So our main direction for future work includes the investigation of the same research question with a different experimental design. We will investigate which measures can be used as a precise proxy to represent the knowledge transfer in both quantitative and qualitative ways, and also which metrics are better to measure the quality of contributions. Okay, so see you at Virtual ICPC 2020.